I'm Oliver, I'm the CEO, but I would like to really welcome Juan. I'm not going to attempt your second and third names because I'm terrible at pronunciation. But Juan is the CEO of GEM, has been there for 16 years and has just a huge amount of experience on mining and how to communicate mining, and has been really kind to volunteer his time this close to the holidays. So I'm not really going to go into much depth, but I think, Juan, I'll leave it over to you to kind of maybe do a little bit more on your background and then take us through the presentations, and we will have questions at the end. So thank you very much, and over to you.
Thank you, Oliver. Well, welcome everyone. I would like to take your word and start saying that I have plenty of experience in mining and no experience at all at deep sea mining, okay? By saying that, why I am here? Because in GEM we are in the basically business of paving the way for the future of mining, okay? We strongly believe that mining is a necessary human activity in the long term. Minerals are required for not only energy transition, but for everything we do. But we also face challenges, and we also need to establish a better mining than what we have had in the past. So by looking to this long-run and better mine scenario, we start studying some technologies and some opportunities for the mining industry, and we realized last year that deep sea mining of polymetallic nodules, okay, was a very interesting way to produce nickel, cobalt, and manganese for the future, not only with relatively good economic terms, but more importantly, with a better proposition in terms of environmental and social issues. We studied other types of deep sea mining, but we don't achieve the same conclusion, okay? By doing science, and in our team, we are engineers, scientists, and we are people of numbers, evidence, and basically science. But we established that with the current technology, the other types of minings in the deep sea were much more challenging, and from the environmental point of view, they were not necessarily better for the environment than the current mining in the land. Okay, so I would like to start by saying that I am going to talk not about science, engineering, economics, but about philosophy. And that sounds pretty strange in this industry, not only in the mining industry, but in this deep sea mining industry. But the point is that we strongly believe that the development of deep sea mining requires not only technology, a business model, social acceptance, but also environmental footprints that are low enough. But all of these requires the social willingness to proceed in this endeavor, okay? And so far, we have understand and learn that the public opinion is mixed. There are a strong opposition of some people. There are some others that want to proceed with this endeavor, and there are some others that are not sure about what the implications should be. So the idea of using epistemological analysis to reveal what the criticisms are regarding deep sea mining of polymetallic nodules is to set a kind of framework of analysis to put all these visions together, those that are opposed, those that are willing, those that are not sure, and trying to achieve a consensus, okay? Which at this point, we are not basically trying to influence the result, but more importantly, trying to, based on science, see what is the best, not only for the sea, humanity, but for the entire planet. Okay? So let me say very shortly something that you probably already know, and is the fact that um, the energy transition that we need requires metals. So basically, we are in the business of changing fossil fuels, which are producing energy, by transmitting energy in form of electricity, but that requires lithium, nickel, copper, and some other critical minerals. So we are changing fossil fuel by metals, okay? And that means we need to produce more metals if we want to replace fossil fuels, okay? The production of metals, however, is not um, has has an impact on the environment as any other human industry. Okay, even this webinar is generating electricity consumption. We are using computers. Those computers are made from metals, etc., etc. So there is no human activity that is has no footprint in terms of environmental footprint. So we need to realize that we are not changing fossil fuels uh, by metals, and in the road, not making any damage or affectation to the environment. We are always going to make some change in the environment. And the question is whether the changes that we are going to do are less costly than the benefits, and obviously whether they can be reversible over time when we get the technology in the future to do it better. Okay, so the whole necessity for metals is making that the world is trying to look for these metals everywhere on land. And right now, nickel is being exploited, for example, in Indonesia, by deforesting huge amounts of forest. Cobalt is exploited in the Democratic Republic of Congo with very, very important social implications. Lithium is extracted in the driest deserts of the world by using water. So at the end, the mining in land is questioned. And not only that, the exploitation of minerals in land by the human being since the last 10,000 years has produced mineral depletion. That means the resources that we have on land are not longer so high quality as they used to be. They are more costly to extract. And that means that we are looking for opportunities to extract more minerals in a cheapest but also more friendly way. Okay. Now, the technologies of the future that we are looking at today is the deep sea mining, but at the end, the last frontier is the space mining. Okay, and we see deep sea mining as a necessary step to go to the space and exploit asteroids, okay, which could be a much better environmental proposition. But unfortunately, we don't have the technology yet to make that economical, okay? So We all know that the debate of deep sea mining is still going on. Okay, there is a lot of opinions in favor, against, and a lot of countries and people not taking any strong position yet. Okay, so the world is facing a kind of point of inflection where we need to understand whether this is something that is worthwhile to pursue, whether the benefits are much greater than the cost, and whether the costs are reversible over time, or simply the costs are too large, or the irreversible damage too persistent to compensate the benefits in the long run. Okay, so the idea of this presentation is trying to figure out how we can analyze the opinions that are out there, that sometimes are very strong, sometimes are very well supported, and sometimes seem to be very weakness supported. Okay, so how we can deal with all these different opinions, all these relevant concerns, all these issues that worry people. Okay, and in order to do this, what we are going to propose is to analyze the opinions, okay, through the lens of the theory of knowledge. Okay, and particularly the epistemology is a science of philosophy, okay, that basically study the distinction between justified beliefs and opinions. Okay, so as you can imagine, it's not the same to have a justified belief than an opinion, and that is exactly what we would like to talk about. Okay, so we are going to talk about beliefs, but we also want to talk about true knowledge. So we understand true knowledge when we know the truth. We said we say that we are talking about beliefs when we believe in something, even if we don't have proofs or evidence or even any link with reality. Okay, so the whole idea is to think that in this particular problem or any other problem in the world, wars, political issues, any problem, this framework can be used to analyze any problem where people disagree. Okay, we have a plane of reality, of what actual happens. Then we have, unfortunately, reality is, from the philosophical point of view, non-achievable. Okay, so we can perceive reality, but we cannot touch reality. Okay, so what we have is the plane of evidence, and evidence is a kind of sample of reality. So in this graph, we are saying, well, let's imagine that reality has this shape and that color, okay? And the evidence is that probably we are not going to have exactly the same shape and color everywhere, but we are going to see something similar, okay? The interpretation plane is how we see and interpret the evidence to infer reality, okay? So what this graph is showing is that if we have different stakeholders, let's say different groups of people, for example, let's say that group A are deep sea miners, okay? When they are talking about deep sea mining. They see evidence in the sea in one way, and they interpretate the evidence based in their own beliefs and their own systems of belief. Let's call it mining, science, any kind of system of belief that they want. But unfortunately, by looking at the deep sea mining problem, we not only have miners, we also have environmentalist people. Okay, and environmentalist people see some other fraction of evidence, maybe not the same than the evidence that miners are seeing, okay, and interpretate that evidence based on their own belief systems, okay. And let's say that the group C is people like any person in one city that are not deep sea miner, are not environmentalist, but they are concerned about climate change, okay? And they believe that metals could make the world transitioning into a better place, okay? And so on, we can have different groups of people seeing different kinds of evidence and interpreting that evidence in a different way. So what is reality in this case? Who has the truth? Group A, B, C, D? Maybe one of them is closer to reality. Maybe neither of them are close to reality. Okay? Why we care about reality? Because we are making opinions, we are making propositions about reality that are basically forming our decisions for the future. And those decisions will not only impact the planet, the sea, but also the wellness of a group of countries, persons, investment for the future, technology that maybe in the future we are going to be able to use outside the Earth. So all these decisions that we are taking now are critical for the long run on Earth. So the question is whether there are some possibilities to agree with each other on what needs to be done. Okay, so let me go a little further by saying that I'm not going to talk strongly about philosophy here because maybe it's not the audience and we don't have time. But what I am saying here is that each group of stakeholders, okay, can firmly and honestly support one belief system. Okay, I am not, and I don't want to talk in this meeting about the false beliefs and everything that is related with the beliefs that are make in order to confound people. So, for example, when I have a false belief, there are four possibilities to believe something that is not close to the reality. The first one is ignorance. I simply don't see the evidence, or I simply have no the framework or this belief system to interpret correctly the evidence in order to be close to reality. For example, I am not a biologist, so even if I have access to some evidence of the polymetallic structure, I cannot interpret it correctly what the impact of the polymetallic extraction could be on the fauna. Okay, that is one possibility of ignorance. Okay, so obviously a biologist should not be biased by ignorance. Maybe I have insufficient evidence. So let's say that we are biologists and we know about abyssal fauna, but we have never been there. We have not samples in the deep sea. We don't know the animals that are there. Okay, so we don't have evidence of polymetallic extraction impacts on fauna. But because we are biologists, we are always thinking that everything could make changes in the biology. Sure, what you eat, what the temperature of the sea is, everything. So even if you're a biologist, you can form false beliefs simply because you don't have sufficient evidence. Okay? The third possibility to create the false beliefs is the misinterpretation of evidence. So I am a biologist, I obtain evidence, but the hypothesis that I make is wrong, which could be absolutely possible. Actually, science is nothing else than the concatenation of false hypotheses. We thought Newton was right. Einstein proved Newton was wrong. Somewhere very soon probably will prove that Einstein was wrong about gravity and the general theory of relativity. So the models are never perfect. The hypotheses are never perfect. So maybe in some cases, one hypothesis that seems applicable in some other places is not longer applicable in the deep sea. Okay. And the last source of forming false beliefs is deception. Okay. It's when you know that something is true and basically you distortion the arguments, the evidence, the interpretation in order to obtain a result that is convenient, but you know is false. We are excluding in the presentation the last source because we strongly believe that most of the stakeholders of any problem, including deep sea mining, are acting in good faith. Okay, and maybe the differences among them is because ignorance, insufficient evidence, or misinterpretation of evidence. Okay, but not deception. We are not saying that deception doesn't exist in the world. Unfortunately, it exists, but we are assuming that lots of people cannot sustain deception over longer periods of time. Okay, so all this gave us the concept of truth likeness. Okay, truth likeness is basically the degree to which a proposition, a belief, is close to the truth. So we are not saying that we can get the truth. Okay, what we are saying is that we can believe in something that is highly truth likeness, or has a high truth likeness or a low truth likeness. Okay, so high truth likeness is related with a high probability of the proposition being true. Low truth likeness is related with a low probability of the proposition being true. Okay, so this is one important concept. And the second important concept is whether the proposition or the belief that we have is simply a speculation. That means an opinion formed without adequate information. Okay, so when you say that the Earth is plane, okay, I would sustain that that is low, it has a low truth likeness. I am not saying that is false, but has a low truth likeness. And moreover, that you are speculating. Why is that? Because the opinion that you have formed is ignoring evidence. Okay, so if you go back here, you are ignoring very good arguments to discard that proposition. You are probably not taking into account all the evidence that is available. You are discarding evidence because you have conspiracy theories and you say that those evidence were built for someone. Or simply you are misinterpreting evidence. So to the speculation is very damaging for any agreement, because when you speculate, it's difficult to sustain a conversation unless the speculator wants to learn about what they are not taking into account or want to include new evidence into their belief system, or simply want to learn what other interpretations are available. Okay? Unfortunately, beliefs are very hard to change. Very hard. If you believe in God, probably nobody is going to change that belief. If you are not believing in God, probably nobody is going to change that. The only possibility to change beliefs is to have a kind of illumination. Okay, is to uh, go to a point in your life where basically your belief systems collapse. Okay, and then you need to see reality from a new perspective. The propositions can also be assumptions, conjectures, reasonable inference, and hypotheses. The point important here is that the degrees of propositions from higher to lower give you an idea of how scientific or defensible is your proposition. Speculative propositions cannot be denied, but hypotheses can be denied. Okay, so the whole point here is trying to bring the conversation to the hypothesis level to have a basis that all the stakeholders can refute or not. But speculation cannot be refuted. Okay? Now, by reviewing, I am not saying everything that has been written, but a lot of what has been written in deep sea mining of polymetallic nodules, with my team, figure out that all the beliefs can be summarized in these 29 propositions. Okay, and some propositions are related with the ecosystem and climate change, some others with technology, some with economy, some with politics and communities. I am not going to list everyone, but I would like to talk a little bit about some of them in order to give you an idea of what kind of, or how these propositions can be understood. So the first proposition that we listed from the literature, the newspapers, the social networks, etc., is that the deep sea mining may cause biodiversity loss. That is one proposition. Some people strongly believe in that. Some others strongly believe that that is not true. Some people is in between. Okay? A second proposition is that deep sea mining may cause disturbance of carbon sinks. So obviously there is also some people that say, okay, if you want to produce metals, do not go to the deep sea because you are going to remove the carbon that has been deposited there, and the carbon will go out to the atmosphere. And that obviously could even increase the problem and not lowering the problem. Okay. Some people say, well, deep sea mining has unknown ecological impacts, and so on. Okay. Maybe some people believe that removing nodules may disrupt food webs. Some people believe that the short-term economic gains may not outweigh the long-term damages. Some people believe that profits coming from deep sea mining will only benefit corporations and not communities, okay, and so on. Okay, mining technologies are uncertain. There are international legal and governance gaps, etc. So if you see these leads that we would like to be an exhaustive list, but maybe you can add some other beliefs. We are not in the position to say, well, this is truth, this is false, because nobody can do that. That is the whole point of the epistemology. There is no truth or false with 100% of certainty. Okay, what you can do is an analysis to understand whether the truth likeness of each proposition is high or low, and to what extent the proposition can be refuted or can be scientific in the way that you can deal with the proposition in order to refuse it or not. Or you have simply an opinion. And opinions cannot be refused. Okay? When you have all these propositions, you can form what is called the map of propositions. And this map of propositions basically tell us that each of these 29 propositions are connected. Okay, and I'm going to give you just one example to show you the connections. When I say connections, I am saying that if you believe in something, that belief supports the belief in something else. Okay, so for example, if you take proposition number 5, which says that mining generates sediment plumes that may affect organisms, that belief is supporting another belief, which is the number 8, that says that removing nodules may disrupt webs, food webs. And at the same time, number 8 could support number 10, that says that concern that mining will scare the ocean floor. And number 10 could affect or could support number 1, which says that deep sea mining may cause biodiversity loss. And then you have number 6 that says deep sea mining may cause irreversible damage. Okay, so this change of beliefs are connected. Okay, if you don't believe in 5, okay, and number 8 is only related to 5, you cannot believe in 8. But if you don't believe in 5, but number 8 is also related with number 3, which is not connected with 5, and says that deep sea mining has unknown ecological impacts, well, even if you don't believe in 5, you still can believe in 8 as long as you believe in 3. Okay, so I am not going to bother you more than I have bothered you now, but what I am saying here is that beliefs systems are connected or are connecting all our beliefs, okay? And a good strategy to go forward in the deep sea mining industry to put all people agreed on the way forward is to analyze these beliefs from the truth likeness and propositions perspective in order to understand what the actions need to be done to refute or not each belief. Okay? And as long as, for example, you refute number 5, but you cannot refute number 3, well, you know that number 5 has a very low truth likeness, but number 3 is unknown. So what you need to do to solve number 3, probably because deep sea mining has a no ecological impacts, is to make science to let those uncertainties or those unknown known. You need to know what is going on, and that means to spend money, to do research, to make environmental studies, and so on, in order to understand and change that proposition for good or bad, but you are going to change that proposition. Okay? So at the end, all this graph has all the beliefs that we think are connecting the propositions in the deep sea mining industry. And if we can basically categorize these propositions in terms of the kind of proposition, whether it's speculation or an hypothesis, for example, or the truth likeness that these propositions have, well, we can identify what are the propositions that we need to care more about because they are likely to be truth or they have a high truth likeness. And on the other hand, they are close to an hypothesis. So the red zone in this matrix is very important, okay? Maybe the orange zone is still very important, but the red one is not important, either because the opinion is simply speculation or assumption, and the proposition has a low truth likeness, okay? So in those cases, we are not saying that you shouldn't do anything. What we are saying is that we need to inform people and stakeholders because probably they believe in this because they are ignorant about what is behind this proposition. Okay? So this is a way to analyze the problem. Here we have the map with the results that we have achieved. Because of time, I would like to give you the opportunity to make questions and maybe comment, but I would like to say that we can provide you these slides and you can take a screenshot for sure. But the idea here is trying to identify what, from these 29 propositions, what should be done as next steps. And what we are saying is that there are some propositions that has a high truth likeness, in our opinion, and based on science, only on science, okay? And maybe what the industry needs to do is to compensate to the different stakeholders or the environmental damage in a way that the benefits are much higher than the cost, and the costs are not irreversible. Okay, there are some other propositions that clearly require more research in order to change the status of the proposition. There are some other propositions that are very unlikely, and what needs to be done is what we call the belief breakdown, is to change what people believes, but in a way that is more consistent with reality. Okay, nobody wants or should want to change beliefs because power. We want to change beliefs as long as we are not only convinced that our beliefs are closer to truth, but also because we believe that the other beliefs are damaging, for example. Okay, and at the end, some of these beliefs required some strategic marketing to be done in order to change the perception of the different stakeholders and the entire world. So what we are saying here as a summary is that deep sea mining is a complex problem, is very, very difficult to analyze because evidence is partial, because interpretations of the evidence can vary significantly depending on the stakeholder, okay? But the epistemological analysis could provide a framework to analyze this problem from the scientific point of view in order to understand whether we as society should pursue it or not, okay? And obviously, always outweighing the benefits, the costs, and the reversibility or irreversibility of the decision, taking into account that there is no human activity, neither mining in the land, nor deep sea mining, nor flying a plane, or some other, or being in a webinar that is not causing some environmental footprint. Okay, so we need to be very practical, but by being practical, we don't need to sacrifice the world, the nature, and obviously the future generations. That is what I would like to, I wanted to talk. This is the team that contribute to this study, especially Pablo Faundes, Alina, and me. If you have any comment, doubt, or anything that you want to know or learn more, or maybe simply give you your opinion, happy to listen.
Okay. Juan, thank you so very much. So everybody, if you you can either type your question in the chat and I'll read them out, or there's a hand raising functionality down along the bottom of your screen. If you want to click on that, I will go ahead and call on people for Juan to answer your questions. All right, Carrie, please go ahead. Take yourself off mute. There we go. Got it.
Thank you, Juan. That was very interesting framework for these DSM propositions. So the one thing that was absent from this framework, and I'm curious as to how you see it fitting in, is values and differences in values.
Values in economic terms, or?
No, societal values.
Oh, okay, societal values. Well, implicitly in the beliefs are values, okay? Because if you think in the propositions, all the propositions are built in a negative way. So that is because implicitly there are some values behind. So for example, deep sea mining may cause biodiversity loss. That means that you value nature and biodiversity. Not sure if that is clear, or?
Well, yeah, okay, I see that that's how that fits in, but I do see that some of the fundamental problems in the public policy discussions of deep sea bed mining really relate to different values. So,
Values or beliefs? Can you please provide me an example?
Well, for instance, the differences in values in terms of terrestrial mining impacts versus deep ocean bottom impacts. Or someone says, you know what, I don't really care so much about the deep ocean environment. I'll never see it. No one will, for all practical purposes, will ever see it. So why should we care? And that's one point of view. And if the difference is, that we don't take out a rainforest, that's where my values lie. So now I'm not, and I just want to qualify. I'm not speaking personally. I'm just, trying to answer the question with that you presented.
Yes. Well, I would add that, I think values are simply part of our belief system. And you can also integrate your values in this change of, or this graph. So for example, maybe the number 5, mining generates sediment plumes that may affect organisms, comes from other beliefs that you have. Whether you are a hydrologist and you understand the plumes problem, or you have only common sense and you have seen how, dust creates plumes when you put your foot in the land, or any other beliefs, give you support to that belief in a greater or lower degree. But at the end, the question is whether that belief is closer to the reality or not. I understand the point of values as society. If you say, well, I am not able to sacrifice nature, okay? But if you want to have an iPhone, you cannot say that unless you are ignorant, because the iPhone or any other cell phone is made of metals, and metals are produced by mining. So at the end, again, maybe you have a false belief simply because you are ignorant, or because you have all these other possibilities that we all have. Nobody has the entire truth, but if we can basically complement our views, our knowledge, our expertise in order to get a consensus. And I think that is what is difficult in this kind of problems, because as in beliefs, that we have in Chile, probably in the same in the United States and some other countries, we say, well, never discuss about religion or politics with nobody. And the reason why is because those beliefs are so strong that you are not going to change them. Okay? Well, there are problems in humanity that unfortunately needs to be discussed. And this is one. Okay, so whether the solution is not going for deep sea mining or going for deep sea mining, this is not a party where we cannot discuss about God or about left and right. We need to be responsible and achieve a consensus. Not all people is going to be happy, but we need to solve this problem.
Okay, thank you. All right. There we go. Let's see. All right. I think Kiran, if you could go ahead and go, and then Kirsten will get you right up there.
Thank you. Can you hear me?
Yes.
Yes.
Yeah, thank you. Thank you, Juan, for this wonderful webinar. I learned a lot, and it reminded me of my studentship days when Professor Max Delbruck gave me a copy of his book on theory of epistemology. And there is so much of thing you have packed in a couple of view graphs, which I would like to study more when I have a little more time and a copy of this view graph. And also as a student of policy in our policy class, we were given this simple definition of what is policy. And policy is, a proposition of a hypothesis, and a policy maker in doing so tries to maximize the complex utility functions of various participants. And how do we do that in a complex situation like this deep sea mining? You really opened my eyes toward big sets of problems and challenges, and I wanted to articulate that. And thank you again for sharing with us this educative webinar.
Thank you, Kyrie.
Great. All right, Kirsten.
Hello. Yeah, this is, I was kind of wondered, I need to look up what epistemology, see, I can't even pronounce it, is. As you know, as a natural scientist, I'm a deep sea ecologist, you don't really get in touch with that kind of science, although of course, Popper is a big name. I find it a bit difficult to agree that I have a belief that, for instance, is number 5. But if I understand your explanations correctly, then that particular belief that mining generates sediment plumes that might affect organism has a high truth. What is the word? Truth likeliness? Is that the right?
Yes.
Yeah.
Yes.
However, so say you do an experiment on that and it ends up, okay, this particular form of mining has that much sediment plume impact. Don't worry about, in which unit we assess that and what time frame, doesn't matter, just a number as an example. Now, as a biologist, I might rate this particular number as much more damaging than, for instance, an equally educated hydrologist or sedimentologist or engineer, because that number as a number in itself is still not that useful, is it? It needs to be put into the context we assess it. And that's
Absolutely.
And then that just a little bit was kind of, hold on, is this a belief or is it?
Well, it's a belief because as a biologist, you can, as you correctly said, give a much better educated view about the truth likeness of the affectation to biology organisms.
Mm-hmm.
However, you don't know how the plume will be because you are not a sedimentologist, you are not a hydraulic engineering, so you have all the theories to understand what kind of plume, to what height, what the velocity of sedimentation will be, what the particle size will be.
But I can read up on it.
Well, you can, but if you are not an hydrologist, a sedimentologist, a geologist, a geochemical, and so on, you will not have the entire evidence or information to make a good statement. As the same for the hydrogeologist, because the other hydrogeologist could say, well, I can read about biology to see whether this is an issue. But again, I think how you form the best view with all these different and partial evidence that we are going to have. The world is so complex. We will never achieve reality as it is. So we only have parts of evidence. We only have our own systems of interpretation. And so what we need to do is to work together for sure, but recognize that there are some parts of the problem that are not known to us. We are ignorant of those.
But I think, I mean, those are, you know, partly the known unknowns and the unknown unknowns, aren't they? They have to be factored in.
Sure, but if you think about that and you say, well, in that case, we cannot do nothing because we cannot pursue something if we have doubts about any type, well, we will
We've done that all our history. All human history is exactly that.
Exactly. You know, the human being went to the moon with the Newton laws, not the Einstein, relativity. And the Newton laws are wrong. And we sent people to the moon to risk their lives just to go to the moon. So the question is, well, that means that we need to do any risky proposition? No, for sure, no. We need to take risks because in the case of the moon, well, if something happens, it will happen to few people, but not to the entire Earth. Okay, here obviously we have a much difficult problem. Maybe not from the ethical point of view, but from the planetary point of view. But again, how we deal if we don't have all the information? I can assure you that even if you read all the hydrogeologist papers, sedimentologist paper, and everything, there is some quantum state of the matter that you are not conscious about, and you will never be conscious about, to take the final decision with certainty. So,
yeah, but I don't see that as a big hurdle in going forward and doing things.
Sure. And that is the way that we humans take decisions. We went outside without umbrellas, even if we know that if there is a risk of rain, but we never go to outside with umbrellas all days because it doesn't make sense.
If you live in Scotland, it does.
Well, yeah, sure. But if you live in Chile, you don't. Okay. And I think what is important here again is we need to deal with uncertainty. We are never going to be. We cannot achieve reality. Reality is an illusion. So what we can do is take all the evidence that we can, all the interpretation systems, and trying to figure out what interpretation of the evidence, as much as possible, fits better with reality, and take decisions based on that. Otherwise, we cannot advance.
Thank you. I need to get my head around all that.
Yes, thank you, Kirsten.
Okay. Juan, we have 2 questions in the chat, and I can read them out loud, or you can read them out loud, whichever you prefer.
Oh, sure. Let me see where is the chat here.
It's down on the bottom right. The third.
Let me. Yes. Okay. Here.
There.
Okay. So the first question, slide 12. Well. The question of Francisca is a very good question. What we are assuming in slide 12 is that we have achieved a consensus between all the people involved, scientists, politicians, everything, and we have adopted one set of beliefs and truth-likeness, and we have decided whether one proposition is simply speculation or an hypothesis. There is only one framework, okay? So no, because if each stakeholder has its own graph, which is the way that the world behaves, we need to make efforts to put together all these graphs and agree on one graph. okay, which is difficult, but it's necessary. We cannot take decisions if everyone has a different graph and a different belief in their system when the problem is common. Okay, I'm not sure if that answered the question, but and the second question, well, not necessarily. I strongly believe that we don't need infinite time and studies to understand what the benefits and drawbacks are from deep sea mining. Okay, for sure we need some more research. Okay, we need environmental studies for each business proposition. Okay, we need to do the things right in the same way that today mining is done in the earth, which doesn't exclude the possibility that some damage is done, okay, voluntary or involuntary. What is important here is to understand that benefits are relatively easy to estimate, okay, and I think the world strongly believes that metals are one way forward to reduce carbon emissions, okay? The costs are in doubt because, to be honest, we know very little about the deep sea, okay? And we are not going to know about the deep sea unless we go there and see what happens. Okay, I have the best example here is the Salar de Atacama in lithium. Okay, Salar de Atacama is the biggest source of lithium in the world. Okay, and it's a salt flat that is related to a fragile ecosystem, and the mine has been working 45 years with flamingos and everything, and the situation is that they can coexist. Okay, now that doesn't mean that it's simple. That doesn't mean that the company doing the extraction do not require environmental studies or conservation programs, or for sure they need everything, and all the insurance they can take, they should take it. Okay, but we are never be able to know exactly what is going on. Okay, so we have been, since the 17th century, we believed strongly in the law of gravitation by Isaac Newton. In the early 20th century, Einstein basically teaches us that is not truth. Okay, it works relatively well in certain cases, but it's not truth. Right now, we know that Einstein is wrong, but we have not corrected the potential error. Even we don't know where the error is, but we know that we are going to change. So do we need to wait for a new Einstein to build a magical formula to send people to the space, Mars, or to put satellites in orbit, or to put GPS in orbit in order to have autonomous cars on Earth? I don't think so. Obviously, we need to be conscious and cautious about the steps that we take to not make irreversible steps. If we are going to make some damage, that damage needs to be small as possible. That is why we do environmental studies and everything. But also, we need to be relatively sure that we can repair the damage if something goes wrong, okay, in some way.
That's great. Thank you. Let's see if we can hang on. Just two more quick questions, I think, Juan. We can
Yes,
do
no,
that.
Kirsten is saying that truth is incorrect. Absolutely, it's incorrect. It doesn't exist. It doesn't exist. What it exists is truth-likeness in the epistemological theory.
I call it validity. You know, something is valid until it's been proven.
Exactly.
Unless, you know, that
But
validity.
you know, science is not looking for the truth.
No, it's not. Not at all. That's not.
Not at all. Science,
No.
you know, the Riemann hypothesis is never to be demonstrated by science, because by science you run your computers, you see what the roots of the zeta Riemann function is, and you every time that you run the computer you figure out that the Riemann hypothesis is truth. But unless you run it by the infinite, you will never prove it, and you will never prove it mathematically by doing science. The only way to prove it is provide a tautological argument that all the zeros in the complex plane are set in z equals 1/2. And that is basically impossible to do with science. So science, we need to be conscious and careful, because science never will provide the final answer.
I think we should talk about the word truth. The word truth is misleading.
Exactly, it's a guideline, and it seems to be a very good guideline. But otherwise, we cannot take positions, decisions, and everything. How long do you think it will take to reach consensus? Well, I think, probably I am wrong, but I think we are close to the consensus, okay? And in my opinion, the consensus will not be to go for deep sea mining at any cost, any place, or any environment. I think what the correct step forward is to each company provide a serious and scientific environmental study with all the protections, with all the risk mitigations, and so on, and then go step by step with a small scales first, and then if everything provides to be fine, advance in larger scales. I see we are close to that point, but it is a political issue at the end, very important, and we need to be conscious on that. So the world is changing, the political winds are changing in United States, Argentina, and many countries, and probably from the political point of view, these new leaders are closer to this kind of positions. But I think the only way to pursue deep sea mining as a sustainable mining is to achieve a political consensus, okay, from on the or most of the society, that we need to advance with risk mitigation in a small scales, and always providing scientific evidence that if, for example, one species is in your area, you are going to protect that species. Okay, in some way, or maybe you do the environmental study, and you achieve the conclusion that there is no way to do mining in that area. I don't think, honestly, the problem is 1 or 0. I think you need to be responsible and do a one-by-one case analysis, plus risk mitigators, plus starting with the small scales, and learn what happens. And then take the options of growing or not growing. But if something goes wrong, you have not achieved an irreversible position for the entire sea or the entire world.